Two particles move in a uniform gravitational field with an acceleration g. At the initial moment, the particles were located at one point and moved with velocities v1 equals 3.0 meter per second and v2 equals 4.0 meter per second horizontally in opposite directions. Find the distance between particles at the moment when their velocity vector become mutually perpendicular. The solution. The two particles were initially at one point and starts moving horizontally in opposite directions with velocities v1 and v2. So let's consider the velocities of two particles at instant of time t. The velocity of particle 1 will be minus v1 I cap minus gt j cap, and velocity of particle 2 will be v2 I cap minus gt j cap. If this instant of time is the time when velocities of two particles are mutually perpendicular, we can obtain the condition that the dot product of two particles velocity will be 0, which will give the equation minus v1 v2 plus g square t square equals 0, or the value of time will be equal to square root of v1 v2 divided by g. At this instant of time, the position of particle 1 will be equal to minus v1 t I cap minus half gt square j cap, and position of particle 2 will be v2 t I cap minus half gt square j cap. The displacement between the two particles will be obtained by subtracting the position of particle 1 from the position of particle 2, which will be equal to v2 plus v1 t I cap. The distance is the modulus of displacement, so we take the modulus of displacement and the distance will be v2 plus v1 t. The value of t is here evaluated as square root of v1 v2 divided by g. So if we put the value of t in this expression, we will get the distance between the two particles as v1 plus v2 multiplied by square root of v1 v2 divided by g. If we put the values of v1 v2 and g, we will get the answer as the distance between the two particles 2.47 meters. Thank you for watching this video.